Defactoring, pace of change, you can read. But what I'm here to talk about is something maybe a bit different from the normal thing that people have been talking about here at the conference, because I'm coming from the digital humanities community, which I'll talk about what that is in just a second. But I'm here to present some work that's very much in progress. It's work that myself and my collaborator, Joris van Zundert, from the Huygens Institute, we've been working on this actually for about 2 years, and I'll explain why. We're going to talk about kind of peer reviewing scholarly code, and we've been working on it for 2 years, so it's probably not a solution to the peer reviewing problem because it's taken us so long, but we like to think of this as slow scholarship, like slow food. But who am I? So my name is Matt Burton. I am a visiting assistant professor in the Department of Information Culture and Data Stewardship, sorry, there's a misspelling there, at the School of Computing and Information at the University of Pittsburgh. Another shorter way of saying it is I'm at the I school, or the information school. So if you've never heard of an information school, these are a set of interdisciplinary academic institutions across the world. And some members, I see some I school people in the audience, so it's wonderful to see them here. But we are a great place to find work that's happening in everything from machine learning to behavioral economics to library science to archives and preservation. So it's a really interesting place to work. And so that's hopefully, you'll see why this is why I work at a place like this. To start, I'm coming from the position or the place in which I'm speaking now is coming from the digital humanities community. Raise your hand if you've heard of the digital humanities. Oh, actually, there's a lot of folks. Now, keep your hand raised if you know what digital humanities is. All right. I think that, okay, so you know more than the digital humanists, because one of the perennial conversations in the digital humanities is the fact that, we're still trying to figure out what is the digital humanities, or what are the digital humanities. There's not even agreement on whether it's plural or singular. I think it is plural. So I'm going to tell you what I think it is, or I'll tell you kind of some of the space in which it occupies inside of the academic community. One way of thinking about it is that I like to think about, we talk about digital humanities as a big tent. So there's a lot of people participating in the community. Everyone from, so traditional humanities disciplines such as English, literary history, area studies. But there's also a lot of participation from members of library science and also people in the library profession. So it's a really big kind of community. And then we do actually have adjacency with some social scientists, especially in the interpretive wing and the qualitative wing in the social sciences. But another way to think about the digital humanities is what they do. I like to think of it, digital humanities, as kind of two sides of the same coin. It's on kind of a spectrum. And on one side, they study culture digitally. But then on the other side, they study digital culture. And so on the study of studying culture digitally, this is a visualization by Benjamin Schmidt, who is at the Northeastern University. And this is some of his dissertation work where he visualized and studied historical shipping logs out of, I think, the whaling ships leaving Massachusetts historically. And so he's a big R user and has created these amazing visualizations of tracking where historical ships were going by leveraging the digitized logs from the shipping records from that period, from the whaling records. So this is one example. Another example of some really interesting and amazing digital humanities work is Orbis, which is essentially Google Maps for ancient Rome. And so you can say, I want to go from Rome to another location, and it'll tell you how long it took by factoring in things like terrain and weather. So in the winter, it may not be quite as fast as it was in the summer. And they've built some algorithms and designed a whole interactive D3 visualization that allows you to kind of explore the Roman world as the Roman world, as opposed to using Google Maps now, which won't probably give you the same answer because there's cars. Although it may or may not say that many lives were lost and somebody died of scurvy. So this is the Google Maps for ancient Rome. One of the things is this is a very media-rich, interactive web application. We like to call this digital scholarship, and this is kind of scholarly output so this is scholarly output. It's a data visualization. This is scholarly output, interactive web application. But there's also, on the other side of this, the study of digital culture. And so these are 3 books. The one in the middle is actually by a colleague of mine at the University of Pittsburgh, Annette V. She's a literary scholar who studies coding and programming as a form of literacy and looking at how programming is changing the act of writing. Another book over here by Dennis Tenian is about the poetics of plain text, the plain text format. So it's not poetry, but it's the form and expressiveness just contained within plain text expressions. And then on the left is a book called 10 Print, which is a code studies edited volume, and they're just talking about that one line of code, 10 print cars 205 go to 10. This is an entire book written on that one line of code. And so this is kind of a very traditional humanities approach to engaging digital culture, in this case code, where you can spend a lot of time in writing and thinking about what does it mean, how does code affecting and changing the way that we write, how does code change the way we think, and also just how are these kind of technical platforms imbricated into the social and cultural practices and the ways that we produce cultural artifacts. So digital humanities community actually is really, they do use Jupyter notebooks, kind of in a lot of the way that other academics are using Jupyter notebooks. We use them for teaching. Jupyter notebooks have been a really amazing platform for the digital humanities community, because digital humanities is trying to teach people programming often that are not, where they're not computer scientists, they're English majors, they're literary students, they don't have the math background, and so they are, Jupyter Notebook allows for this really fun and amazing, kind of interactivity and kind of gives kind of ways in which we can teach programming that's not the traditional Towers of Hanoi computer science, let's make the Fibonacci sequence. Because those are not meaningful examples for humanists to scaffold on. Instead, what's more interesting is opening up historical texts and then using machine learning to process them and using topic modeling to see what topics writers were working with. So I like to think of the digital humanists are these unicorns that everybody's been looking for. And so digital humanists, they can definitely write. They can sometimes write too much, but they can communicate extremely effectively because this is a very important aspect of humanities education. So what's cool about the digital humanists is they can talk to humans, but they can also talk to machines because they're also learning to cut code, and they are building systems like Orbis. That's a very complicated web application with all kinds of JavaScript. And actually, Elijah Meeks, who is the lead developer on that, he wrote one of the great books on D3.js, and unfortunately got poached to Netflix. So he's no longer working at Stanford University in the library, which is sad, but it is a good outcome. I want to see more digital humanists going out into industry and bringing the critical perspective as well as the technical skills. So it's not necessarily, it's sad for us, but great for the world. And this is one of the things that's really key about the digital humanists is they can think critically about the information technologies and the implications of these technologies and what kinds of worlds that we are building when we are building sociotechnical platforms. Another way we like to talk about, we can hack and we can yak. So I want to talk about the code that digital humanists are writing. So if we're producing digital scholarship and we're using computational analysis to analyze digitized texts, we got to use code. So HathiTrust, if anyone doesn't know, there's the HathiTrust, which is a collection of 14 million books. It's basically Google Books for scholars. And the thing about it is 14 million books is a lot of books and it's too many to read. Traditional methods in which humanities researchers, doing close reading doesn't necessarily work because it doesn't scale to 14 million books. So then we've kind of begun to turn the community to computational analysis, natural language processing, machine learning, and all this sort of thing. And when you do that work, there's a ton of code that is written. But then the question is, when you go to publish, and when you're writing about what you found in these digital collections, you will write either a traditional print monograph or a journal article, but the code it disappears. And the issue here is twofold. Part of it is a cultural problem, and which is that the code and coding of scholarship is not seen necessarily as the code that is associated with scholarship is actually not seen as the scholarship itself. And this, Bruno Latour has talked about this as kind of a philosophy of purification, mainly in the scientific context, that science is a process of purifying the assemblages and the complicated messiness of science into these kind of purified, reified, circulating references of points of information. But others have written about kind of this, there's this artificial opposition that exists between intellectual and material labor. And so that there's the intellectual work that we get credit for, but then there's the material work of writing the code, but also the material work of digging through an archive and going through and traveling to various archives to collect materials that become the evidence in your argument. None of that work that is work that goes into the work, but that work is not necessarily work that can count in itself, in many parts because there's no inscription, i.e. there's no writing or there's no object that you can, that is associated with kind of the traditional work of digging into the archive. But this is different with code. Code in and of itself is an inscription, it is an artifact, it is a thing that can be used and circulated with, but it doesn't necessarily count as a piece of scholarship. And so what many are arguing now in the community, at least from a theoretical perspective, is that this focus on the intellectual work and on the argument just exclusively obscures what might be possible, what might be a set of other kinds of scholarly output that we're not necessarily attending to. And a big part of this, though, is also issues around credit and attribution. So especially if you're a scientist, who's doing a lot of the coding, and are they first authors, or are they even authors on your papers at all? So there's these enormous theoretical and practical and cultural issues around the labor and the material labor of writing code and how that is rendered visible in the systems of scholarly production and credit, getting tenure, getting promoted, all this sort of thing. Is it citable, et cetera. So what happens, more practically is, you have data, you have code, it goes into this kind of purple box. I don't like black boxes, so I like purple boxes of analysis and interpretation. And then they go through the obligatory passage point, the big red wine of scholarly communications and peer review, and they get shoehorned into the JATS XML data format so that they can go into the publication format and ultimately end up as a PDF. But what happens is the code and the data, they hit this wall and they bounce off. And this doesn't, so there's, not only is it a social and a cultural problem, it is also a technical issue. What's amazing is there's a whole bunch of work happening with Jupyter that is solving the technical problems, but they're not necessarily, the social problems are always the more difficult problems. So ultimately, I think a lot of people in this community would agree that code alongside data and maybe even also computational environments should be part of the scholarly product. This is important for open science and reproducibility. because you need to have all of these materials if you want to be able to reproduce a scientific result. The digital humanities community is not necessarily as interested in reproducibility in as much as they are interested in understanding the decisions and the biases that are embedded in the code and in the data in order to understand can you make a claim about this given the way that you did your sampling, or how did you normalize the data, and does that, is there other ways in which we can do that in order to kind of come to a different conclusion? So it's similar. There's both communities, in the science communities and the humanities communities. I think they want the same thing, but for possibly different reasons. So ultimately, the issue is the cultures and infrastructures of knowledge production in the academy. They ignore or even occlude the code work of scholarship. And this is, this is the problem we've all been talking about. The previous session was talking all about this. The guys from Figshare. This is why we have, it's all tied up with, traditions and habits and rituals of publishing for scientists and humanists. It's wrapped up in the economics of scholarly publishing, which, when there's money to be made, it's very difficult to change, to break away from that. And I would say, the last person was saying, would you want to publish in some unknown open access kind of journal thing, or would you want to publish in Nature? And while I myself would want to go into the weird, funky new thing, most of my colleagues would definitely go to Nature. Or not Nature because they're humanists, but they would definitely want to publish with Harvard University Press. So the way that we think about this, or the way that I like to talk about this is a socio-technical problem. It has social dynamics, it has technical dynamics, it is a socio-technical problem. And in which case, you need to kind of think about socio-technical solutions. So we can address the cultural problems, we can, people can resign from the editorial boards of for-profit journals and start their own journals. We can have technical solutions like Jupyter and the platform and all the rich expressiveness that Jupyter allows. But we need to kind of tie these together in kind of a socio-technical way. And so this is what we're working on, my colleague and I. What we're working on is a technique or a method for peer reviewing code, and we call it defactoring. And so the idea here is create an approach for peer reviewing digital scholarship, which is these kind of computationally enriched scholarly publications, or that could be web applications. But what we're going to focus on, well, I'll explain exactly the narrow focus that we have. But we're trying to take the socio-technical approach because it has all of these dynamics around. We need this. The digital humanities community actually wants this. The culture is ready for it because they want to give credit for promotion and tenure for doing digital work as opposed to traditional. Instead of producing the book, which is the gold standard for humanities promotion and tenure, people want to give credit for digital work. But there's a challenge because, especially when you're reviewing it, and this was also pointed out in the previous, the session in this room, that it's very difficult because there's varied technical literacies. If you want to have people peer reviewing code, people need to understand how to peer review code and understand the code. And a lot of academic disciplines, not just in the humanities, but in the sciences as well, people are not literate at programming, and especially certainly not literate enough to begin digging into the code and reviewing it and making judgments upon it. And also there's an interesting tension around, because if we're talking about code, there's kind of a catch-22, I think, around a lot of people advocate for best practices from software engineering. So for doing test-driven development, for doing breaking things up into reusable modules. And I actually don't think that those are always necessarily the best practices that are going to be appropriate for digital scholarship and scholarly code. For some cases they are, and for some cases they are not, and I'll explain those in a second. So what we really need is some practical methods and techniques for reviewing actual code. And so this is what we are trying to do, is we're focusing on some specific digital humanities code, and a specific kind of code. So what I want to also introduce is to understand exactly what code we're talking about is Conrad Hazen has this he had a blog post about scientific software collapse. It was published in early 2017. And he came up with kind of 4 layers of scholarly, or he was saying scientific software, but since I'm also talking about a broader thing, I use scholarly software. But he talked about these 4 layers. At the bottom layer is general purpose software. So this is operating systems, Linux, Mac OS. And this is software that's not necessarily, it's designed to be extremely general purpose and to be used by a ton of people. Operating systems are used by all kinds of people all over the world for a lot of different reasons. But then there's, on top of general purpose software, we build scholarly software. So scholarly software is a lot of scientific software, built for specifically an academic, like the scientific community writ large, or the digital humanities community writ large, or just all of us. So LaTeX is a great example of this, although people in the general purpose community and publishing use LaTeX. But R would be another example, I'd say, of something that's kind of scholarly, although it's been blown out into a larger community. But these are fuzzy distinctions and fuzzy layers. But on top of scholarly platforms and scholarly software is disciplinary software. So this is the code that's written for just astrophysics. Or we have in the digital humanities, we have a bunch of, and even we have sub-disciplines within the digital humanities who have specific software that they like to use. Another way to think about this, although I didn't draw it, is a pyramid of which how many people what is the size of the audience that's interested in this software? And so disciplinary software begins to narrow. But at the very top, you have what is, I think, what we don't necessarily talk about is the bespoke code. And this is the one-off scripts, the glue code, the stuff that we put into Jupyter notebooks. And this is stuff that's not necessarily meant to be written for other people to use. It's not general purpose. It's not generalizable. It's for the generation of a specific result. It's tailor-made for working with a specific data set and transforming that data set and running a specific analysis. And I want to make a really big distinction between the bespoke code and then all of the more generalizable stuff. I think the generalizable stuff, the layers, the general purpose scholarly and disciplinary libraries and things, those should probably follow the best practices of software engineering because they need to be bug-free and they need to be reliable. Bespoke code, there's another, some people talk about this, why it's okay for scientific software to suck, I think what they're saying is they're talking about this bespoke code and the scripts that, they just need to work to get to the result. But they can't be terrible, obviously, and they need to work in a way that produces the result that we expect. And it's this bespoke code that I think we actually needs to be enrolled into peer review processes and be reviewed alongside the publication that it was used to produce. So what we have done is we have targeted some bespoke code in a scholarly digital humanities project. So Ted Underwood and Jordan Sellers are a set of digital humanities scholars. They're literary historians. And what they have done is they have created a classifier that basically looked to see, took poetry volumes. So they took about 720 poetry volumes, collections of poetry, and they had some pre-existing labels. So they knew some of them had been reviewed in a poetry review journal, and then some of them were drawn at random from the HathiTrust Digital Library. And then they kind of used logistic regression on 3,200 word features, and they basically created this classifier that is, roughly accurate. You can kind of see this is my hand-drawn version of what it looks like, but you can see it's roughly accurate. Everything above the line is reviewed, and everything below the line is random and not reviewed. They wrote a lot of Python scripts in order to create this. So they drew their data from the HathiTrust. They wrote a bunch of Python scripts that they were they put up on GitHub, which is not necessarily a normal practice for digital humanists. They actually put a preprint on Figshare, which was enormously helpful for us in terms of understanding. The preprint was a bit more, it was really helpful for us in terms of understanding what the code was doing and giving them some of their their thinking around methodological decisions. And then finally, though, it did actually produce a publication in Modern Language Quarterly. And what's interesting about the Modern Language Quarterly is, with the exception of this one figure, there's almost everything that exists, the data, the code, and the preprint, all of that stuff is not really part of that, that final publication. Because that final publication is written to satisfy the expectations of literary historians publishing in one of their premier journals, Modern Language Quarterly. Most of the people in that journal have no idea what scikit-learn is or what a logistic regression is. And if they see those things, even if they see the term data, they get a little antsy or irritated or afraid, depending on, I think, where their egos are at. So what we did is we focused on the code that they put up on GitHub. And we were, it was all there, and we were able to kind of download it and rerun it. So the code and the data are all bundled into a Git repository. So you can just run their Python scripts, and you can just generate this. You can generate this graph just by running their script. So what we did, and so these are in Python files. So what we have done is we took the code from Pace of Change, and we defactored it. So we took, if refactoring is the good practice of breaking stuff into modular components and putting them into modules and libraries, we went the opposite direction, and we defactored it, and we converted it into we put it all into one single Jupyter notebook, and we broke down all of the nice separate namespaces that they had and the modular components, and we made it into a single literary narrative that's running as very procedurally through all of the code that they wrote, or most of it. Some of it we did not bring over in this process. But this was the key first step for this this exercise of peer reviewing this code, was getting it into a linear structure, so that then we could begin to do, and putting it in also crucially into the Jupyter notebook, because the Jupyter notebook allows us to execute it, but also to read it and to write about it all in this one nice platform. And so this is where the socio-technical nature of our technique works in. Is it's not just reading the code, it's actually reading the code in the Jupyter notebook and executing it and running it and engaging with it. So what we have now is this Jupyter notebook filled with their code and our annotations, and it's both human and machine readable. And so it creates this really interesting, what everyone has been talking about in terms of computational narratives. So what it looks like practically is, so there's code cells which contain the code that Underwood and Sellers wrote. And then we broke all of their code up into, their stuff is all in one mushed together in a couple of Python files. So we broke it all up and commented out function calls and kind of mushed it all into the Jupyter framework and broke it up into code cells. And then what we did is we just wrote and kind of dug into the code. And what we did was we performed kind of like a literary analysis, a close reading of the code, and we write about what it does. And so we really got into it. I mean, we've been spending 2 years working on this, which is probably why this is not a great technique for generalized peer review. This might be more of like creating a scholarly digital edition. And we've dug in, and we've actually gone through and annotated all the pieces of code. We also created a narratological structure. So I created a table of contents for the code, because there's distinct sections that do various things. And so we kind of frame it more as a narrative to make it more legible to the humanities and literary scholar audience. Another thing we've been able to do is actually interrogate the code in pieces and sections, so we can run half of it and then interrogate the data structures and create our own plots and look and see what does the code look like as it's running, and then continue the computation. One of the interesting things that comes out of this, though, is that I frame this as the bespoke code is the engine of intermediate representations. And so what I'm saying here is like the Croakers is the poetry volume. It gets digitized and turned into a bag of words. And then that bag of words gets transformed into a feature matrix, and then that feature matrix gets transformed, it gets normalized into just one row in a pandas data frame. And so we kind of see this is like a lot of the code is just doing this transformation work. Most people will call it feature engineering, but I like to say you're getting the data into shape, so you're doing data fitness. Another thing that's really interesting when we dive into the code is we get to see specific decisions that get made with respect to normalization. So Canada is now part of the US and Ireland is now part of the UK. And this is their comment. They apologized to their Canadian and Irish friends. I don't think they ever realized that I would be presenting about this at a conference and highlighting their embarrassment. But I told them I was doing this and they were okay with it. So then the real question is, what are the next steps for this? Like I said, this is still a work in progress. We've been working on it for a really long time. It actually right now is a Google Doc that is around 60 pages. And so we're going to publish this as its own independent journal article, but we want to publish it as a Jupyter notebook so that you can read it, but you can also execute it. So maybe I need to talk to the Figshare guys about a platform for publishing a living notebook that you can run it. It does have a little bit of computation. It takes about 20 minutes on a quad-core machine because it's doing a whole bunch of logistic regression, but nothing very big. And this is one of the things about digital humanities work is it's not always necessarily really big data. They might be taking and sampling from big data, but the size and scope of their work is actually not too big. So it actually fits really nicely in with Jupyter Notebooks as a mechanism for publishing. And so with that, I'm going to leave this blank and open it up for questions. Thank you. Yep.
Your notion of defactoring got me thinking about a tension I've often experienced when doing data analysis or writing code is that on the one hand, you come from a software development background, you're taught to break things down into packages and modules, write reusable functions and so forth. And then on the other hand, if you're working in this style of Jupyter Notebook or some other kind of interactive documents, it's a more linear structure. You want to tell a story.
Right.
And these are both nice things, but there seems to be some tension between them because it's not so easy to have both. It seems like it's not so easy to reuse things that are in a Jupyter Notebook necessarily, or attach a narrative to a larger code.
Yeah.
You might say that, like, well, like one of those is the bespoke and one of those is the disciplinary, but it seems to me that the boundary is often quite fuzzy, and I often find that I'm not exactly sure how I should do things, and I'm just wondering what your thoughts are.
I think you're exactly right that there is a so the question's about the tension between the style of code that we write for bespoke code versus the style of code for software engineering. And I think you're exactly right. And I think because Jupyter is so new, actually Stuart Geiger gave a really fun talk about this, kind of talking about this issue is we're in a situation now where we have a misalignment of expectations. And so Stuart was talking about the emergence of film in respect to theater. And so when they first were doing, I'm sorry, Stuart, I'm just going to have to take your analogy because it's so perfect. They used to put video, cameras, just plop them down in the audience and film a theatrical production. And I think we're in that moment with Jupyter. Or actually, I don't think that. Stuart thinks that, and now I think that. But that's the place where we're at right now is we have a misalignment of expectations, and we don't yet know, because it's so fuzzy, what we're doing, and I think with time and with the good examples, we'll probably begin to see some more clarity about when something is really, it should be it should be abiding by the expectations of software engineering and best practices around that, versus this new computational narrative, which is like, you're not writing software, you're writing code in the pursuit of insight. And I think that we're just now really having those conversations. Although those conversations have been having for a long time, we're really in it now I think with Jupyter. So great question.
Yeah, so some of this work reminds me, I don't know if you've heard of he did like all this, he called it forensic biostatistics, where he was going back and recreating this analysis that had shown like this gene was associated with cancer, and basically found that was bogus for both kind of like Excel off by one errors and also more like malicious, like added genes in the microarray and actually their errors. And so like with that was years of work for him. And
Yep.
so I guess like for that one, it's like there were clinical trials and people were getting the wrong drugs, and that was like a really big
The stakes are the stakes are different for this.
Yeah, and so it's like exactly like how do you feel like on the topic of ritual, like how do we weigh when this is worth it versus when it's not? Like, what is it? Mike Dyson would just be like, just publish it. Like,
Yeah, we were talking about this in the last session. I mean, this does not scale.
yeah.
because it's taken us so long to do. And I don't have a great answer for that. I mean, I don't think that maybe this level of peer review shouldn't happen to everything. But things that, if something gets published and it gets a lot of attention, so this got a lot of attention because it was one of an early project, and they put all their work out. So because this got so much attention, we began to focus on it more deeply. And maybe you just kind of have to follow the attention economy and say, well, things that are, people are ascribing drugs to should probably get a greater level of scrutiny than other things.
Yeah.
So, yeah. Saya?
When you're doing a mapping of code to narrative, it seems like there's something very fundamentally different, perhaps, between what code does and what narrative does. And I'm interested in sort of your views on that. It seems to me that code essentially has two layers, right? You're applying code to something to generate something, so it's not what you see is what you get, right? But whereas narrative is watching a narrative performance or reading a narrative, there's just one layer to it. As you mentioned that some of these tools are using methods of big data to smaller data, and so that suggests that what you get might be very much inflected by the size of the data, and a method that is significant for large data may not be so for smaller data. So I'm wondering, that can notebooks give you a way to express some of these things, the kind of hidden, mysteries of code, if you see.
Yeah. Yes. So this is actually one of the things we're writing about. Let me think. I have a slide on this. So we have actually, this is an unfinished slide, but there's multiple narratives. There's several different narratives, and we actually treat the code as a narrative. We treat the execution environment as a narrative. So there's a bunch of different layers of narrative. We still haven't really figured out what that all means. So this is the part that we're actually working on, is the implications of all that. But I think your point about layers is exactly spot on. And we see there's a MLQ narrative, there's the Figshare narrative, there's a GitHub narrative, there's the fork of our narrative, there's the Jupyter notebook, there's the computational kernel that's running as a narrative that we're engaging with in dialogue. So there's a whole bunch of stuff, but we haven't really teased out. I mean, Jupyter is just one of many access. It's just a window into. It is a narrative and a window into a computational narrative. So we're still figuring that out. Question here.
I'm kind of curious about the relationship between something like Donald Knuth's ideas behind literate programming and
this is a direct descendant of Donald Knuth's literate programming, I would say. I mean, that's the notion of computational narrative directly references that work. And so I think we're definitely, the affordances of information technology now enable something that maybe, that he was, I think the vision that he articulated, we still haven't gotten there because he's brilliant, and that we're still kind of trying to get there. And the Jupyter notebooks, I think, will get us to that point for sure, I hope.
Do you think that people who are actually producing this work, rather than relying on their reviewers to then sort of decompile all the other stuff and then recompile in a sort of beautiful document way, do you think standards in the community could just be in order to submit something, submit a notebook?
I would love that, but that's, again, it's the sociotechnical challenge. I think we might get there for some smaller, like Digital Humanities is a community that is small and enthusiastic about this, so we might be able to do that for the Digital Humanities or a subset of the Digital Humanities, but I think the key, that's the key, start with very small communities in which you have a social network or that everyone can kind of get on board with this, and then see if it scales. I mean, that's how preprint started with high performance computing, is it was just a small community that was sharing their stuff. And now we have archive and bioarchive. So start small, think local, or act local, think globally. I don't know, question here?
I guess following up on the view thing, when doing the defactoring, do you find yourself limited by having to talk about the code in order? I think with web and C web, what it allows you to do is describe code out of order and say to lead with the here's the meat of it, and talk about it, talk about the lyric style, and then be able to have the more boilerplate afterwards.
Yeah.
That gets retangled together.
Yeah, I know what you mean. We actually decided to in part, the way that Underwood and Sellers wrote the code, there wasn't a lot of boilerplate. So I could see the boilerplate problem being an issue. Like we actually wanted it to be a linear narrative, and to be really, because if you start getting like hypertextual and start doing these kind of moving things around, like one of the audiences for this is like people who have no experience with code, and I think we would lose them immediately if we started doing all that fancy stuff. But I do think the boilerplate problem and like how do you I mean, we put all the code in there, and we just wrote about all the code, and but it worked for this case, but it may not work for others. Other questions? Yep.
You spoke about sort of the hierarchy of generality, right, between sort of like low-level operating systems going all the way to bespoke code. And you talked about that sort of in a scientific context, right? The way we started the operating system, we come up with like a particular scientific analysis. It seems to me like that's true for say, application development. We write applications and they rely on operating systems, but you have sort of like the business logic of your application, which does something that's specific to the domain that's not going to be reusable. Do you think that, traditional programming applications would be improved by being transliterated into this style, or do you think there's something unique about, say, scholarly or scientific publication that makes this form more appropriate?
I don't know. I haven't thought about there's definitely, so you're talking, like there's, in the business analytics space, there is this like bespoke stuff, like where business intelligence or whatever is in that.
Web servers, right? Like you have a server that's built on a framework, but it does something that's specific and not reusable.
I see what you mean. That's interesting. I hadn't thought about that. I mean, mainly, this framework was written by Conrad Hinson for science. I have adapted it for scholarship and digital humanities, but it'd be interesting to think about for. I mean, I still think like a web app, like a Rails application or something like that, would still probably sit. I don't know. That's interesting. I hadn't really thought about that. I'll have to think about that some more. Good question.